Good morning, Alex here. And if you are here, it's probably because you're tired of having to deal with infrastructure. Maybe you've tried infrastructure as code and you've ran into environment issues and how to manage all of that. Well, there's this article here from 2023 that comes from Vercel that I just want to have a little look at today because they're coining this thing called framework defined infrastructure. And I think it's more than ever relevant for us to look at. So, if you're like me and you're always trying to optimize your dev workflow, well, this video is going to be just that. We're going to dive into how framework defined infrastructure can help improve your developer experience, but also how we can expand the Next.js defined infrastructure with our own custom infrastructure needs and things that we need also when we're deploying our applications. This is a big mind shift I've had this year where I want more of the things that I do in my application code to be orchestrated with code that comes from around it. Maybe it's in your repo, maybe you're doing bundler plugin, maybe you're doing code gen like some of the big libraries. And if you want to learn all these tips and tricks, be sure to check the video that I've linked in the description. I did 5 of my repo tricks that are actually advanced that this video builds on top of to provide additional insights into how I integrate that into my development workflow. So, what is framework defined infrastructure? And how does it solve infrastructure as code? The idea behind framework defined infrastructure is that the deployment environment automatically provisions the infrastructure derived from the framework and the applications that it's written in. So, what that means is at build time, the program or the plugin or the bundler, in the case of a framework, parses the source code and determines what is needed in terms of infrastructure configuration to run that software. This is actually one of the reasons people complain that Next is hard to deploy. And it's because the way a Next app gets bundled actually creates multiple separate artifacts that each need to be deployed on a different infrastructure. So, statically rendered pages, you want in some sort of CDN. Pages that are dynamic will run in Lambdas. Your middleware might be in Edge, and your assets might get optimized as a separate thing as well. So, when you receive the output of a next build, you actually have all of these independent things that you actually have to deploy to all these different types of infrastructure. So hosting a Next app is not a static app you just put somewhere. You actually have to take all the individual parts of it and put them in the corresponding infra buckets. The advantage, however, is if you have hosting platforms that support hosting your applications, well, they understand this and then they will provision the infrastructure for you. And so you benefit as a developer of not having to worry about this, but also that every build that you end up doing, in say in a separate environment, can provision the infrastructure for that build specifically. This is how Vercel does the preview environment for all of your PRs and your different branches. And it allows you to have all that infrastructure provisioned on demand for any kind of spin up of an environment that you want, including running locally in your dev environment. You have substitutes for all of these things. And this is not specific to Next either. The other frameworks are moving in that direction as well. Gatsby has a concept called deferred static generation, which expects you to deploy its output in different places. SvelteKit now has form actions. And now in 2025, we also have the new Vercel workflow dev kit, which even provisions things like queues in the background for you. So libraries, not just frameworks, can also define the infrastructure that they require. This has been common in the past for some hosted services. You may think of, say, Convex or Trigger.dev, but these libraries that you write code and then it just works in the backend kind of rely you on using their third-party service. The way Use Workflow works, or these open source frameworks such as Next work, is they just bundle the output for you, and then the hosting provider has to implement how to deploy this infrastructure. So you don't necessarily have to deploy to Vercel. You could build your own adapter and deploy it like some do on Coolify with OpenNext and things like that. Use Workflow is actually the library that made me change the way I think about infrastructure. And I think it does this really well. It has this concept of worlds, which is kind of this adapter pattern for specifying how to deploy this library on some infrastructure. So it even comes prepackaged with a local world, and Vercel implemented the Vercel world. So when you're running use workflow on Vercel, it can leverage Vercel queues, which is a new beta package on Vercel. But ultimately, community driven worlds can actually define different ways to provision the infrastructure for running this library. So although this article speaks about framework defined infrastructure, I think we're also moving in the direction of library defined infrastructure, which to me is very exciting. Like I hinted at the beginning, one of the biggest challenges with infrastructure is actually to have different environments that you work in, including your local development environment. So if the infrastructure problem is considered in your framework or your library, it actually will most likely solve the local problem for you, and it will have a way to run locally. The framework or the library is also aware of which environment it's running in, and if there's differences in how it operates, it can handle that for you as well. Local is one thing, but you also have multiple branches or deployment environments, and you want the infrastructure to match that. What the article is suggesting here is everything nowadays, if it's in code, it's also in Git. And so you can have deployment at the commit level. And again, this is how Vercel handles creating preview environments, and it does a build for your PR branches. This makes sense from a server compute perspective, but when it comes to other infrastructure that's going to be more application specific, like a database, you won't get the benefit of this kind of working out of the box because it's not defined by the framework. It's something the developer adds after the fact. So this is a reason I really like services like PlanetScale that have branching at the database level, because you can mimic this with your setup for your database as well. You spin up a new database instance for that specific deployment, and then you just have in the build that it connects to it. Currently, you still have to set that up, but if PlanetScale had a client, say SDK or a library that could define the infrastructure that's needed, you wouldn't need all that automation in your CI. You could just rely on the usage of the database to provision it based on the intent once it gets built or bundled at the time of the build of your app. And I really think this is the direction that things are going in. People really like third-party services like Convex that handle all the infra for you. But if you're a library author and you want to require some infrastructure, this is the pattern that you should follow to enable the users of your library to provision the right infra for the requirements of your library that you're writing. And so, as I do in the age of AI, I've actually tried to build something like this for one of my use cases, which is I wanted to have Upstash and specifically QStash from Upstash following this pattern where I don't have to manage all the infrastructure. And QStash is a good use case here because it doesn't have branching in the way PlanetScale would have for your database. So I have to solve this problem in a framework or library way where this is all defined in the code. And then when I deploy my application, I know what's the intent of the code, which queues are needed, which endpoints are subscribed to those events, and how to provision all of this. So let me just show you the code that I came up with and how I apply this pattern to that specific use case. So if I head into VS Code here, I'll show you my end goal and what I was able to achieve. So basically, this is just a plain Next.js app, and I wanted to define queues that I can kind of pub sub style, just publish messages to and subscribe on the other end in a serverless way. So when I'm creating the queue, I have this client here. I just call create queue. I specify the payload of the messages, and then I give it a name. Off of this queue object is where I can actually publish a new message, or I can also handle messages. So this is not your typical infrastructure as code definition of what needs to be provisioned. This is actually runtime code that I'm going to use to publish messages to this queue. If we look in my API routes, I have a few example routes here where I'm doing queue.handle message, and then I have the a simple route endpoint, Next.js style, that will be listening to all of these queue messages being posted. In this case, I've actually built this around Upstash. And so when you look at the implementation, this handle message handles things for the developer, such as verifying that the Upstash signature is applied, and not everyone can call that endpoint. But like I said earlier, this library that I'm developing wouldn't have to be Upstash specific. It could, just like the use workflow library, define worlds using, again, the adapter pattern for different implementations. And then Upstash would just be the adapter that I choose to provision the infrastructure that corresponds to the intent. But how do you extract the intent of what infrastructure is needed from the code? And this is actually the interesting part of what I've built. I want these queues that I defined to exist in the infrastructure. I want to provision a queue that is going to be called sample queue whenever this app is deployed in a new environment. And in order to do that, I ended up building a Webpack plugin, a bundler plugin to go and navigate the abstract syntax tree and find all of the calls to create queue, extract the name of that, and package all of that up into a nice little intent file, which is what I'm calling, for what infrastructure is needed to run this code. What that looks like is I have this with Upstash function that actually wraps the next config and adds the plugin to Webpack. And I know writing bundler plugins is intimidating, but this is just code that's not your application code. You're a developer. You can handle this. So this with Upstash call actually comes, wraps my Next.js config, and I can even, in this case, provide an output directory .generated/upstash. And if we go to that folder, you'll notice it creates a registry file where all the queues are identified. And also in this case, the destination of where the messages should be published so that the corresponding infrastructure can be provisioned. So this registry tracks the intent of what infrastructure is required. You can also obviously generate types for all these things. And now my client itself is aware of those types. And so when you go and you try to use a queue that is not in the registry, meaning you haven't bundled your code yet, the name could give an error like this not a real queue name is not assignable to the queues that are in the intent of the registry. So from a developer perspective, you just create your queue, you give them a name, you run next dev or next build, and then the generated intent is going to be captured in that registry file that we just saw. I've also baked in some logic for appending, say, the branch name to the queue names so that when you're doing things like preview deployment, you're not publishing to the same queues that might be tied to different endpoints in that specific environment. And so you can actually take this intent and provision it for every deployment, the same way Vercel does its preview deployments for your compute. So it ends up being all seamless. And as a developer, I didn't have to manage a Pulumi config or an SST config in my repository to specify the intent of what my infra. It was actually inferred from my usage in the code itself. And I have a feeling that when I'm going to be using some additional infra, I'm going to start approaching it more this way so the devs on my team don't really have to think about how things get provisioned. I still have yet to take this registry and provision the infrastructure. So write the code to call, in this case, say the Upstash REST API endpoints to provision that infrastructure. And ironically enough, I'm thinking I might convert this into a Pulumi config to provision that infrastructure. So I'm leveraging infrastructure as code as a tool here, not as the source of truth for my infrastructure intent. Anyway, this is all I have for you today. I hope this shifts how you think about infrastructure as code, framework-defined infrastructure, and the direction I think the industry is going with even library-defined infrastructure. If you're curious about the example I showed in this video, everything will be linked down in the description. And if you're curious about how you can level up your game in terms of writing bundler plugins and doing codegen, be sure to check out my 5 tricks video that I published last week, because sometimes the best solution is not to write application code. It is to write code around your application to make the developer experience better. Be sure to like, subscribe, share with a friend, and I'll see you again soon.